Hello, my name is Braden Stump, and I'm the Director of Product and Business Development here at Aerosol Devices, a division of Handic Scientific. Today, I am here to do our final of our three main aerosol collector classes training videos on the Series 110B, the spot sampler aerosol collector. This is our oldest flagship product, our aerosol collector, and there have been many versions of it. This training YouTube video today is for the newest rendition of it, the Series 110B spot sampler. However, much of this training will transfer over to previous versions, the Series 110A BC, the Series 110A, and the Series 110. Regardless, I hope that this is valuable, and if you have any questions along the way about your specific instrument, please feel free to contact us via aerosoldevices.com or by reaching out to me via email. Without any further ado, let's get to the training. So the purpose of this presentation today is not just to have a demonstration of the physical instrument that I have here, but also to understand how the spot sampler operates, why it operates the way that it does, and why that method is useful, so that you all will have the ability to not just operate the instrument, but troubleshoot it if experiments are not going as well as you'd hoped. So we are looking forward to having kind of an understanding of the instrument's operation and then going over how to actually run it during a sample. With that, let's kick over to part one, which is effectively kind of our theory and scientific review section. I'm going to try to keep this clipping along decently brief, but I want to have enough of a background developed here to make sure that you can lean back on this when we're thinking about how the instrument is running and why. Something to note here is that there is another YouTube video that we have up that goes into this theory once again more. Feel free to look at that if you have more interest, or contact us, or even look at the publications and literature if you'd like to know more. Cool. So the thing that I like to start with remembering about any sort of water condensation growth tube collector sampler is the three primary niches of how these instruments operate and what makes them useful compared to other aerosol sampling technology. The first thing that you're going to see is efficient capture of very small particles as well as over a wide range. So particles from 5 nanometers all the way up to 10 microns, you will expect to collect with efficiency of 90% and up into liquid, and then 95% and up onto solid substrates that you choose to sample with. And that's a really wide range. Low-end nanoparticle capture is a pretty interesting special skill of our instrumentation. Additionally, specifically with this instrument, we have seen very interesting, very cool publications from groups like Virginia Tech be able to capture virus, bacteria, and other microbes viably, still alive, still infectious upon capture, or to capture them into genomic preservative. So there is a gentle capture method here that is pretty unique that allows you to do a lot of infectious bioaerosol studies, or be able to preserve DNA and RNA upon capture due to this gentle collection method. Finally, you really also can see concentrated and convenient sampling substrates, different methods of sampling onto things like SEM stubs that can go straight into an electron microscope, into liquid vials of an appropriate small size. The world is your oyster as far as the sampling substrate that'll be ready for analysis downstream. So be thinking about the flexibility of sampling and the efficiency of sampling as we're going over how the instrument operates. Great. So the core theoretical technology at the center of the spot sampler is something called a water condensation growth tube collector, or a CGT condensation growth tube. This central technology here was developed by Aerosol Dynamics, and we thank them quite a bit for us being able to license that technology for sampling aerosol of any kind. I'm going to skip to this next page here that I think helps be able to show the theory and show how this method works and why it captures things the way that it does. So effectively, when you are thinking about a water condensation growth tubes, the center engine of what allows the spot sampler to operate, you are thinking about three basic systems. You are thinking about a water injection system, so a wetted wall here, a wetted wick here, keeping effectively this wet on the inside of the flow path. You are thinking about an airflow system. So you're thinking about air coming through at laminar flow through this tube here that we call the growth tube. And finally, you're thinking about temperature changes. And those temperature changes go cold, hot, cold before sampling onto your sampling substrate. What this happens, these three systems in combination, what they do together is they actually mimic the human lung. What you are seeing happen here is as aerosol down to 5 nanometer comes into the growth tube and flows at laminar flow, this cold conditioner and this wet-walled wick start to get the flow to a set known temperature here. And it is the jump, the delta T actually, this change in temperature, this increase in temperature with this wet wall from the conditioner to the initiator section that effectively creates a fog here. You see extremely high supersaturation occurring in this region that forces condensation onto particles as small as 5 nanometers. And what that means is you're starting to grow these little raindrops in this growth tube that as they grow larger and larger and larger up to this 3 micron size, and if they're above that, they get water around them, but it doesn't matter as much, right? We can then very efficiently impact them inertially. So they're not able to round a corner effectively and be captured onto liquid or any surface below your nozzle here. Specifically, what's nice is because you are just wanting to make sure that your jet to surface distance here is a certain amount, we are very much agnostic here at Aerosol Devices as to what is beneath the nozzle. So in your experimental setup, be thinking, what would be most useful for me to have below the nozzle, and what can we sample onto, filter substrate, liquid of any kind, genomic preservative, water. We've seen people do glass slides, aluminum foil. The world is your oyster as long as you are able to get particles, to hit it downstream of the nozzle. Finally, you will also see this moderator stage here is here because if we went just from cold to hot, we would have this giant soupy, very much condensed high water vapor flow entering our sample downstream. And we don't want too much condensation to create water and to create a mess down there. So the moderator, after this droplet nucleation has occurred, pulls a little bit of excess water vapor out of the flow. Its temperature is actually user settable, and depending on what temperature you have it at, does not really affect droplet growth appreciably to change your scientific effect of your sample, but it allows you to control liquid gain and loss in your liquid vial, and to make sure that if you're sampling onto a solid substrate, that you don't condense too much water in there and blow all of your water out. So you're maintaining a concentrated sample. One thing that I also like to bring up of note here, in this graph here from the literature Herring et al. 2014 on water condensation growth tubes, you will see that although the wall temperature is quite warm in the initiator stage, you will actually see that the majority of the flow stream never reaches that wall temperature. So even though we do have a warm region here, you are not actually putting a lot of thermal stress on your bioaerosols, your aerosols, your particles in much any way. Additionally, the resonance time through this growth tube is only about 0.3 seconds, I believe. I would have to get an exact value to know, but you're really, you're barely flashing this stuff with a thermal change of some kind. So you're not going to see too much effects from, temperature change, stuff like that, thankfully. That said, I like to do a small comparison to show, as far as what we do and what we say on the tin, as far as the value of our instrumentation, you will see what you should be expecting is from 5 nanometers all the way up to 10 microns, 90% efficiency and up on our instruments. That is very useful because viruses, of course, operate in this lower size range of particles to capture. Of course, any nanoparticle that you're looking to capture, and you have uniform collection efficiency across these wide ranges, right? If you're capturing something that is somewhere in this middle section here, it's nice to know that you are reliably going to be operating at the same collection efficiency. Instruments like the wet-walled cyclone here and the SKC biosampler here do have advantages of being higher flow. However, keep in mind as you're sampling that because our efficiency is so high, we kind of punch in a weight class above what you'd expect, right? 15 liters per minute at 10% efficiency is effectively the same as 100% efficiency at 1.5 liters per minute, right? Long story short, you should be seeing efficient collection with our instruments across a wide size range, especially compared to other instrumentation. One of the things that I also like to highlight as well with the spot sampler specifically is that this instrument has a very wide range of sample substrate options. So you will see as kind of one of our standard units, this sequential spot collection module, there is a time-resolved 33 position well plate here that you can have be made out of PEEK, aluminum, or other substrates that you can place things like filter substrate, glass slides, anything that you'd like to do for solid surface sampling. We don't like to say dry because you also can sample onto genomic preservative soaked filter substrate in these wells. But long story short, you have a great option for time-resolved sampling here for chemical analysis and biological analysis that maybe doesn't involve viability. Additionally, you will see a liquid sampling module brought up here. This is for sampling into a known liquid volume that you start with in your sample of anywhere from about 300 to 700 microliters. These polycarbonate vials are very much nice and concentrated and are really nice to port downstream to methods like PCR, qPCR, other assays, stuff like that. I will note liquid sampling specifically is the most convenient method that we have found our users and collaborators to use in specifically viable bioaerosol sampling. Additionally, you will see that we have scanning electron microscope stub sampling module mounts for this application as well. This is more for people doing semiconductor industry stuff or microscopy stuff. This is also a time-resolved. Oh, sorry, I dropped my SEM stub. I'll go grab that in a moment. Time-resolved positions, but with less positions with the option for larger and different substrates. I go grab that SEM stub for a moment so I can show it off again. Whoop. It seems to have gone missing. I will need to find it later. But yeah, very much useful for the microscopy folks that are interested in the SEM stub collection. Additionally, I mean, this is pretty standard for all aerosol samplers, right? But we like to tout, you can put cyclones on the inlet of this to cut certain high-level particle sizes out to get more bang for your buck out of what sample collection you're doing. As well as we recently designed a tool that we're calling the TLC that is able to interface with our liquid sampling module and control our liquid sampling module for a longer period of time and maintain liquid level for 24-hour continuous liquid samples on the same sample, to have this hyper concentrated, 500 microliter sample. So all things to think about in your experiments upcoming and more. There's plenty of custom work that we've done for users as well. The spot sampler is our oldest flagship instrument, has a lot of ability to customize to your aerosol sampling needs. Great. Just wanted to go over finally a few use case examples of the spot sampler and where it fits into our instrument portfolio as far as what experimental operations it's been used on. It is primarily used because it is a flexible sampler. It's been used in aerosol chemistry, bioaerosol, sea spray aerosol, and beyond. As our oldest instrument, it's gotten a lot of different use. And also because it is our only instrument that we sell right now with the capability to do time-resolved sampling in some way, shape, or form. The instrument itself can operate at a flow rate of 1.2 to 1.5 liters per minute, with 1.5 liters per minute being the default. Sampling surfaces, we already discussed. Its size is about 20 inches by 12 inches by 10 inches, which we'll show in a bit. It's about 18 pounds, and it is our flexible, time-resolved aerosol sampling instrument. A very cool recent publication that we saw from Hawks et al. At Virginia Tech was able to capture viable SARS-CoV-2 from hamster studies. So the paper Infectious SARS-CoV-2 is emitted in aerosol particles. It's a great read. You should check it out. That actually used a liquid spot sampler. We've also seen it be utilized at the Scripps Institution of Oceanography, so to be able to detect enzymes in sea spray aerosol. Then we've also seen plenty of aerosol chemistry studies. This is from Aranza at Aerosol Dynamics, her actual characterization paper on the instrument itself. So it's been used for a lot of very cool different things. Awesome. Now we are on to part 2, more of the fun stuff, how the spot sampler actually operates. Prior to actually turning over to the instrument, showing how it's unpacked, operated, all that stuff, we are going to go over a few things that help you understand how the instrument works. But I will just start kicking into more of the practical stuff here. Before we begin, just a reminder, this is an overview on how to use the spot sampler. Definitely get your hands on the manual still and make sure that you're acquainted with that. It's got great backup information. Additionally, I really like to make sure that folks are thinking about their sample plan and their experimental plan while this training is happening. And even feel free to contact me afterwards just to confirm that everything makes sense. We have seen a lot of times where the spot sampler is operating as a black box, but maybe because of upstream or downstream conditions, they end up seeing more failure than they'd expect. A very good example of this is operating in too high or too low of aerosol concentration conditions for sampling and capture itself. That said, that kind of tees in well to experimental setup. So one of the things I like to bring up just to make sure that people know, because not everybody using this instrument has a background in aerosol science, is to use static dissipative tubing if you're going to be connecting to the inlet of the spot sampler. Aerosol naturally has some form of charge to it. And if the tubing that you're using leading into the sampler is not static dissipative, it can build up charge along the walls and suck some random amount of aerosol to the walls. That's, of course, very worrisome, primarily because it's random error prior to the sampler even getting the aerosol in. So you have no idea what you have lost or how much you've lost. So definitely you're going to want to keep an eye out. McMaster card, these part numbers here are all static dissipative and work well. Feel free to reach out to Aerosol Devices if you need the right part number, or you can use metal, so metal or conductive material. This also includes fittings. You kind of want the whole flow path of where your aerosol is coming from to the instrument to be conductive or static dissipative. If you're just sampling with the inlet normally, don't have to worry about this. And then the final thing to note on this is that the inlet of the instrument is 6 millimeter OD, which means you can buy 6 millimeter ID tubing, or you can also, I believe it's 3/16 ID tubing works pretty well, because a 1/4 inch tubing is a little bit loose because a 1/4 inch is 6.35 millimeters, and you want to make sure that you have a tight fit on the inlet of your instrument. But yeah, feel free to reach out to us on flow, hookup, setup, stuff like that. But it's really important that your experimental setup is able to meet the needs of your instrumentation. Additionally, one other thing to think about is where you'd like to place the inlet of your instrument, or the inlet of the tubing of your, where your sample aerosol is coming from. Let's say, you've got your spot sampler here and you have a patient here that you're looking to capture bioaerosol from. And then there's an HVAC inlet right here. That could be pulling all of your aerosol out of the way. So you really want to think about where the aerosol source is that you're wanting to measure from, where the instrument itself is. The spot sampler is really pretty quiet. It's in the 35 decibel range, I think, from a meter away from the instrument. So, thinking about where losses could occur of aerosol not entering the inlet is a very useful thing. And then finally, just make sure that there are no kinks in your tubing. You don't want to lose, micron-sized particles and up to something as easy as making sure that your tubing doesn't have a bend in it in some way, shape, or form. Cool. Second thing that I want to make sure that we look at is the flow path. This flow path diagram is also in the manual of your instrument. And what you're seeing here is a diagram of it that looks effectively, you could trace it verbatim inside of our instrument. These 3 main systems that we talked about in the theory section of airflow, water flow, and heating and cooling still are here. So I'm going to hit the next on there. Perfect. To show this off. The air handling system, what we're seeing is a vacuum pump here at the very end of the flow path. I'm going to hit the annotate button. 1 second. There we go. A vacuum pump at the very end of the flow path here that is pulling your airflow all the way through the instrument. I bring that up as important because if your liquid vial or sequential, if your sampling substrate is not installed, or if your trap bottle has been removed in some way, you will not get flow through the growth tube of your instrument. So if you're drying your growth tube out or wanting to get a sample in some way, shape, or form, you always want to make sure that you have that 1.5 or 1.2 liter per minute flow at the inlet of your instrument, because that confirms that all of the flow is getting through your system. Any interruption along that flow path along the way means that you're not going to see the flow that you need to through the instrument itself. Additionally, the water handling system you'll see is handled by 2 different pumps here. So a water injection pump is injecting water onto the initiator of the wick of the growth tube. And then a second water removal pump is pulling wastewater dripped off of the wick off back into your waste bottle. A common misconception here, water from the water injection and water waste pumps does not in any way interfere with your liquid sample. Those are separate things. Water removal is occurring off of the wick, and as excess water drips off of the wick, the only thing that is actually blowing and sampling into your liquid vial is droplets condensed from your aerosol flow. So unless something is going wrong, you should not see liquid gain and loss occur from water injection or extraction. It should fully be a function of the aerosol flow, being blown over your vial. Additionally, you'll see the growth tube heating and cooling sections here. We've got the conditioner, initiator, moderator as discussed. And then the nozzle temperature, we just keep slightly heated to make sure that there is not any condensation on the surfaces going towards impaction. And then the sample is just heated when you are sampling onto solid substrates like this. All right, very cool. Final thing before we get to go to the fun of interacting with the instrument. Accessories. This list of accessories is the most updated list of accessories from the Spot Sampler Series 110B aerosol collector. You'll note that there's a lot of things here, and this is because if you are sampling with a universal spot sampler, which is liquid sampling and sequential sampling, versus just a sequential sampler versus just a liquid sampler, you'll see a lot of different parts and accessories present here. But no matter what, you will always have the primary spot sampler main growth tube instrument, a user manual, some form of sampling substrate, and then ways to communicate to the instrument. We'll look over other things as well, a nozzle removal and replacement tool, some syringes, and then power supplies and power cords. This is just something to note that you will see a lot of different renditions of sampling based off of what substrates you purchase from us, but you will always see the base growth tube unit. And speaking of that, I do not actually, on the unit that I'm going to show you today, have a sequential assembly nearby. I will probably need to make that another video of some sort. And the manual also does a good job of explaining how to do sequential sampling. So we are only going to be able to do liquid sampling today. That said, it's pretty self-explanatory. There are other menus that we'll still go through just to kind of look at things. But that said, it'll be a little bit shorter, a little bit abbreviated compared to what you typically expect. That said, without further ado, I am going to stop screen. And then you can also look at your user manual. I'll be able to send along this PowerPoint as well. And we're going to go to the demonstration section. Perfect. I'm going to rotate this way. Ta-da! This is the spot sampler. As you can see, as we discussed, 18 pounds, relatively benchtop size. Currently, there is a liquid vial installed in here, which I will pull out when we are ready to do so. For 1 moment. Got a little dry in there, so it's stuck. There we go. So first thing we're going to do is just look at the spot sampler from a glance, right? So at the top of the instrument here, you will see the inlet. The inlet also has an inlet cap that should be removed before you start sampling, because if not, you will not have any air or any aerosol come in any way, shape, or form. This is the inlet here. It is 6mm OD. If you're needing to get access to the wick to wet the wick in a potentially faster way, if you're not wanting to wait for the liquid pumps to inject, you can remove these two screws to remove this part. That will allow you to use some form of syringe to directly dose the wick with either water, or you can use isopropyl alcohol to decontaminate the wick from this position. Just a quick way to do a cleaning procedure. If you do that, either way, you should not have a liquid vial or the sequential installed, because you'll be kind of dosing liquid fast and extra stuff might drip out of the bottom. With that, though, we will keep circling around here. I think I'm going to end with the front button panel. Actually, we'll start with it because we'll be looking at it a lot soon. What you can see here, and we'll zoom in on this in a moment, but I won't move the camera for now because I don't want to have to deal with readjusting it. You'll see a pump button over here to the left of the instrument. This pump button is for turning the air pump of the spot sampler on. The air pump being on is effectively what determines when a sample is started and stopped, just because when air is flowing through the growth tube, particles are being impacted. At that point, you'll want to make sure all three systems are ready and operating. So you want to make sure that the wick is wet, temperatures are correct, airflow is going through the growth tube by making sure you have a substrate installed. However, that said, this is for turning the air pump on and off. You'll see up and down keys here. These are for indexing through the menu system on the instrument. They are typically for changing values or moving around. You'll see the enter and escape buttons here. Enter is for confirming an option or going further into the menu structure. Escape is for going back. So pretty self-explanatory. Next, I'm going to look at the bottom of the instrument. I'm going to turn it this way. Oh yeah, convenient handles on both sides. How fun. So there we go. You will also see down here, there is a trap bottle with an inlet on the inside here. I'll rotate that a little bit. Inlet facing the inside of the instrument. The trap bottle, as we saw in the flow path area, is right after sampling into this liquid vial occurs. The point of it is to, if there's any liquid in here, that means that sample has overflowed from your liquid vial sample and is being blown out into the trap bottle itself. It's a protective measure for the orifices, etc., inside of the spot samplers further down flow path. If you see liquid in here, something has gone wrong. It is a nice indication of error in the system. Additionally, you will see, and I might lift this up as well. Perfect. The nozzle sampling section here at the bottom of the instrument. I will, you'll see that there are 1, 2, and 3 threaded holes to attach the sequential of the spot sampler onto and in place if you are using the sequential. We are not going to be using the sequential today, but it's worth noting. As well as right here, this is where your nozzle goes into the instrument. Since I've got this angled like this, I just want to be able to show it so that I don't have to show it later. Your instrument comes with a tool that allows you to unscrew and screw back in different nozzles for sampling on the instrument. For sampling, for sampling into liquid, you're going to be using the 3-port liquid sampling nozzle. And for sampling onto solid substrates, you're going to be using the singular jet solid sampling nozzle. They are labeled in your accessories, but it's worth keeping track of. So I'm going to make sure that that's tightened again. I didn't mess with it, but I like making sure. Tighten, tighten, tighten. Great. That is also where your vial is installed. Right here. And you'll want to make sure that when you're installing that it is pressed into place. It is an internal lowering groove. If you're having trouble getting it installed so that it's parallel and flush with the bottom of the instrument, you can put a little bit of grease of some kind that's, non-outgassing for whatever application you're using. So, Vaseline is fine. Isopropyl alcohol, water, all help. to help install and kind of wear that O-ring in, but dealer's choice. This is actually where the growth tube itself is. We'll turn all the way around. And finally, the back of the instrument. So on the instrument itself, you will see the supply water bottle. This can be opened at the top, and you'll be filling this with distilled water, deionized water, ultra pure water, anything cleaner than tap to make sure that we're not damaging our wick material in the instrument over time. This silver goes to silver. And it clicks into place. If you're ever needing to remove it, press the button, make sure that that's pressed down to reinstall it. Additionally, this is your wastewater bottle. I'll turn this way. You'll be emptying this and pouring it out because excess water from the wick will be coming out into this bottle when it is removed from the sampler. Both of these bottles are made of high-density polyethylene, very much cleanable. So you should be able to clean them with most standard cleaning methods: isopropyl alcohol, hydrogen peroxide, the whole shebang. Both of these will need to be plugged in to do any form of sampling because this is how you wet your wick and extract water off of your wick. Additionally, you'll see the serial number for the instrument, which we will ask you for in the event that something is wrong with your instrument and you're contacting us to repair it. This vent on the back of the instrument is what keeps all of your growth tube stages able to get to temp because the ventilation is flowing out through this vent. Please don't cover it because your instrument would not work right? And then your firmware load button, which does not very rarely come up, but useful to know where it is, as well as your data stream port. If you're ever wanting to connect to the instrument via a computer, to access it, if you wanted to attach it to a computer and then access that computer remotely, or just to get log file and data off of the instrument, you can use the included USB-B port in your accessories kit to attach it to the data stream port to send commands to the instrument, stuff like that. This isn't a required thing, but it does allow you to control the instrument in different ways, depending on what you all like to do. Additionally, you will see here, this is the port that you attach the two cables coming out of the sequential. If I had a sequential for time-resolved rotating solid sampling, I would show you how those are plugged in. They're just quarter turn connections, but I don't currently have one on hand. Additionally, this is the pump exhaust port. This pump exhaust port is the same as these ports up here. We also include in our accessories kit something that you can click onto here to run the pump exhaust of your system somewhere else. If you want to run it into a bio hood, through a HEPA filter, back out into the atmosphere, whatever you're looking to do. The system already does have, it is heavily filtered prior to coming out of the system. It's filtered twice, I believe. However, we do understand that people like to be able to run that exhaust somewhere else. So that is what we do. Additionally, you will finally see on the back here, the on and off switch. Up is on, 1 is on, down is 0, of course. And the power plug-in, the power inlet port. We are actually, since you have to keep the waste bottle empty and the water bottle filled, the next step in our demonstration is to plug the instrument in. So I will grab this. This is our power supply that comes with the instrument. Looks the same no matter what. This, while the instrument is off, plugs in to the back of our instrument with the flat end up. You want to make sure it's all the way in so things don't overheat. And then depending on what international region you're in, there'll be some form of cable that plugs into a wall plug that you plug into your power supply. So from there, take this, plug this into the wall. And then when we're ready, which we're not yet, but I will in a moment, we can turn our machine on. Click, and it's ready to go. Cool. Prior to doing that, I did want to talk about different sampling media that you can use in the instrument, just so that you get an idea of what you can be sampling into. We have seen folks sample into liquid vials with a port. Oh, there we go. With a port on the bottom of them to be able to slowly extract and do through vial options. We now offer the ability to do a vial with a port on the side to kind of create a flow through scenario. We also have vials with a port on the bottom that you can extract to bring to other locations. And we have these closed 300 to 700 microliter vials that you can use just for pulling out a sample, pipetting from it, and then, pipetting more liquid in, taking a sample, pipetting it out. We've recently developed the tool called this TLC, which I've talked about, that can have this single liquid vial run for 24 continuous hours for a very concentrated aerosol sample. So you can contact Aerosol Devices for more information on that. Additionally, I like to show off that we have different options for our sampling well plates. You can see this is an example. There's a TEM grid in here. There's filter substrate in here. You can also, if you really look close, you can see depositions in the wells that are about 1 millimeter in diameter, about the size of our solid depositions on the instrument. Or aluminum material. The last one was made of PEEK. I also like to show off, we've recently started making these teardrop wells here. And the purpose of these is to make it easier to extract filter substrate from out of the time-resolved wells, just so you can get a set of tweezers in there and pop stuff out. They both function the same way. They both fit into the standard sequential. You will need a separate sequential for this, and I wish I had a 25 millimeter SEM stub, but our SEM stub sampling setup here can fit 5 25 millimeter SEM stubs or 5, other SEM stubs of smaller size. As you can see, I have a smaller one in place because the SEM stub that I was, here it is. Or there we go. There is a 25 millimeter SEM stub installed right there with a little tool here that this sits on that allows you to pop it out with a set of, tweezers and stuff to get this into a scanning electron microscope. You can also install up to 1 millimeter thick of substrate onto the top of this, or you can purchase clean room spec substrate from us as well. Long story short, lots of things to sample onto. People have sampled into phosphate buffered saline with bovine albumin. They've sampled into artificial saliva, genomic preservative, water, onto pre-cut filter substrate, membrane filter, glass slides, aluminum foil, TEM grid, SEM stubs. Anything that you want to put under the nozzle is an option for your experiment. So we're ready to help as need be. The next thing that I'm going to go over is the growth tube and wick. We have already shown in here. We will talk more about it. It is rolled filter material, so it's not often replaced, and it's very cleanable. So you'll just want to make sure to clean it over time, and we'll start moving towards operating the instrument. So I will turn the switch on the back. I'm going to grab this connection from my camera. I apologize in advance. It's going to be a little shaky, but I want to be able to show stuff on the screen as time moves forward. So the first screen that you will see after the instrument turns on is effectively kind of a splash starting page. So you'll see liquid spot here. That means it knows that it does not have a sequential installed right now. It knows that it's warming up, and what these ones and zeros mean is that the stages here have reached their set temperatures or not. The 0 means they have not reached their temperatures. The 1 means that they have. This is the time that it believes that it is. Your time should be set before the instrument leaves, and we can hit the enter button to enter the menu to change settings on the instrument. So the first menu you will see here, if we hit enter on it, is the status menu. This is the area that I like to be when I am running an aerosol sample when I am not changing settings. Gives me a lot of nice information. Shows me the conditioner stages temperature, initiator stages temperature, moderator, the nozzle. The sample temperature is not active because there is not a sequential installed right now. A stands for the ambient temperature or the case temperature, and it doesn't need to be at a set temperature, but it's an indicator of how warm it is inside your instrument. F is your flow rate in liters per minute. So if I press the pump button here, which turns the air pump on, it should start to increase, as we see here, and show that the airflow is going to start controlling to the nominal 1.5 liters per minute. You can see also that this says on in the top right-hand corner. That tells you that the air pump is on. As a reminder, this does not tell us what the inlet flow is. It just tells us what the flow through the pump and airflow path is. So for example, because we do not have a vial installed right now, inlet at the airflow at the inlet, excuse me, is still 0 liters per minute. And it's not until we install a liquid vial in here that the airflow at the inlet would be 1.5 liters per minute. So I'll turn the pump off, and we'll hit the escape button to look at other menus. The next menu you will see here is flow. We'll hit the down button, and then we'll hit the enter button to look at it. This allows you to see the flow rate sample flow in liters per minute, both what it is reading here on the left, so it's reading 0 because it's not on. If I were to turn it on, it would read different. And also what our set flow rate in liters per minute is right now. If you want to change it, you can hit the down button to decrease it anywhere from 1.2 to 1.5 liters per minute. I like 1.5 liters per minute, so I will not be changing it. But if you were to hit enter here, a star would appear next to this value. I'll just show it off and then start the sampling pump from there. I want the flow rate to be 1.5. Sometimes the buttons do a little movement past where they need to be. It can help to just tap the button quickly. That said, we now are back at 1.5 liters per minute. As the confirmed value, the star means that it's confirmed. Great. On to the temperature section. So you can see what you are seeing in degrees Celsius is the actual temperature that the instrument is reading. And then when you hit enter, it allows you to set the temperature of that stage. So when we're not entered in, you can see the actual temp of the conditioner is 14C. When we hit enter and you see 2 arrows, you can show the set temp on the conditioner is 5C right now. The initiator set temp is 35C right now. Moderator set to 8. Nozzle set to 29. Sample set to 35 when it is installed. So one of the things we'll talk about right now, as a small aside, is what temperatures to have your spot sampler at. There is a table in the manual that should be able to give you a great starting point as to what temperatures to have each stage on your spot sampler. When you're doing solid sampling, you'll want the conditioner as a default value at 5, the initiator at 35, the moderator pretty low for solid sampling, probably somewhere 8 to 12 degrees Celsius. Your nozzle at probably 27 to 29 degrees Celsius, and your sample at 35 to 40 degrees Celsius. What you're trying to do, you're trying to have the right delta T between the conditioner and initiator. So you can have that be higher and lower. Instead of 5 and 35, you can go 10 and 40, but you want a 30-degree delta T between the stages. We recommend 5 and 35 because it's what our system is designed around. The moderator, we want lower to pull more water vapor out of our airflow prior to sampling onto the solid substrate to keep our samples dry for solid sampling. If you are okay with having a little bit more water vapor in your sample, say you're sampling onto genomic preservative soaked filter substrate, then that moderator temp can be higher if you so choose. The nozzle, we're just trying to keep condensation from forming on that surface. So anything above ambient is great. 27 to 29 is about the sweet spot for making sure that you aren't evaporating your droplets too much, but you're also not getting condensation on your surfaces. The sample temp is meant to heat localized your area where you are sampling to make sure that water from your droplets contacts the surface and then evaporates away. So 35 to 40 C is what we found to make sure that you are getting a high quality sample that evaporates any extra water on impact. For liquid sampling, however, you are trying to do something different entirely. For liquid sampling, your delta T needs to be larger to have efficient impaction. So you'll need a conditioner of 5C and an initiator of 40C. So a 35 degrees Celsius range on liquid sampling. And that default is shown on liquid sampling when you're doing it. This instrument is going to be going out as a sequential spot sampler, although the sequential is not yet ready. So that's why it's at 35, but liquid sampling is 5 and 40. On the moderator, you probably want the moderator somewhere between 10 and 20 degrees Celsius. For liquid sampling, you're not having to worry about too much condensation of liquid into your sample. You're more worried about evaporation from your liquid sample. There's something we'll talk more about later. The nozzle temperature stays the same, and the sample temperature is not utilized on the instrument in the same way as before. That said, the TLC that you can buy that adds onto the bottom of the instrument and controls the liquid level of the vial does create a sample temperature under there. So that is temperatures. Sorry to interrupt our discussion of the user interface, but figured that would be worth discussing. You're going to go out of the temperatures area here and back to the menu. Also, sorry, this is backwards. I do not have a way of fixing this being backwards, so you just have to believe me if it looks a little weird. The next menu is collection module. You do want to have auto detect on most of the time. This sequential versus liquid allows you to tell whether or not you are using the sequential time-resolved collector on the bottom of the instrument. And once again, I don't have the time, nor do I have the equipment to show off the sequential right now. This will become more prevalent if you're using a universal spot sampler and wanting to have the sequential operate. But it should auto detect. This menu allows you to change the date and time on your instrument, which I will not be messing with right now, but it does have a real-time clock in it. And then we will see our water injection menu. So we have a water injection menu and a water extraction menu. These two menus are there for different purposes. Our water injection menu is there to wet the wick, as well as to keep it wet during an experimental sample. The water extraction menu is there to protect the wick and remove excess water off of it to make sure that you're not flooding a sample. So your water extraction method right here, what you're seeing as this period function is how many seconds between a 20 microliter injection from a little solenoid pump that you're pulling water off of the wick, which means you always want this number to be lower than your water injection period. We want to make sure that we are extracting water from the wick 2 to 3 times, ideally 3 times or more often than we are injecting water onto the wick, so that we are removing more than we are adding, so we're not flooding the system. A default water extraction period of 30 seconds is great, and a default water injection period of 1 minute and 30 seconds, so 90 seconds, is also great. You might need to increase this value if you're in a really dry environment, and you might be able to decrease, you might be able to, excuse me, I'm going to rephrase that thought. You might be able to increase this period, so inject water less often if you are in a high relative humidity environment, because water will naturally condense onto the conditioner wick. So you might be able to get away with a 2-minute, for example, injection period in a high RH environment. However, in a really dry environment, you might need to have your water injection period be something more like 60 seconds or 30 seconds because the wick will dry out faster. If you do make this period lower, so more frequent, let's say you have a 60-second water injection period, I would recommend also lowering your water extraction period. So making your water extraction period 20 seconds, right? So 60 seconds here, 20 seconds on extraction. Additionally, in order to initially wet the wick, as this wick is dry right now, you will do a thing called adding counts to the wick. The period function is always happening to keep the wick wet over time during a sample. However, before a sample occurs, you will want to make sure to get a lot of water onto the wick and also to fill these lines from your water injection bottle with water. So what you're going to do is you're going to hit the enter button here to go into the counts menu, and we'll just press the down button to put in 250. And if we hit enter here, what this will immediately do is it will inject 250 quick solenoid counts of water onto the wick. What that means, sorry, I'm going to hit escape on that. That's a little bit distracting. My apologies. What that means is that we're immediately adding a bunch of water onto the wick that will then immediately wet it. Typically, you'll need about 500 counts. So you'll need to go through this 250 injection period here, count here twice to fully wet the wick. However, the way to truly know that your wick is wet is to make sure that coming from your extraction bottle, water is being removed to your extraction bottle. The primary reason for that is that if water is being pulled out to your extraction bottle, the wick is saturated enough to drip excess water off of it into the extraction path. Great. Water injection, water extraction. Sampling schedule, I won't have the time to go over right now, but you'll be able to use the real-time clock on the instrument to effectively set a timer to run timed samples if you choose. This method and function here is optional. You can use the timer on the instrument, or if you're doing a lot of swap back and forth samples and you're manually operating it, you can turn the air pump on and off. So it's up to you whether you would like to have to manually turn the instrument's pump off or to be able to set a sample of a certain number of hours and minutes here and time it and arm it, etc. But I don't have the time to show that right now. Manual well advance is for the sequential of the instrument, allowing you to directly go to a certain well of the sequential. So this time resolved well right here. And then find home is a very useful thing that allows you to rehome and effectively calibrate the sequential on your instruments. An important thing to do to make sure you're actually sampling in the right well before you begin your samples. The final thing that we are going to show off here is drain and dry. But prior to that, I just wanted to show airflow verification on the instrument. As long as you have a vial installed here or a sequential installed here, so this airflow path is getting all the way to here, the top of your instrument, you should be seeing airflow at the inlet. However, for folks that want to, you might want to confirm or verify exactly what your airflow is. What you'll want to do is attach an external airflow meter here to measure that, because that is the airflow going through your growth tube, going through your sample. So if you want to verify your airflow, you will connect it at the inlet. Great. The last thing I want to show off is the drain and dry function. The drain and dry function is a menu structure that walks you through how to prepare your instrument for longer term storage and shipment. An important thing to keep in mind here, you can leave the instrument wet over a weekend. I would say as long as it's clean, maybe even a long weekend. But if you're going to store it for a week or longer, you really need to do a drain and dry procedure to make sure that the wick does not grow mold, that it doesn't corrode components in the instrument. We don't want standing water in a warm area here. So the drain and dry function, what that proves to do is, excuse me one sec, walk you through the menus to do it. So first you'll attach an air filter at the inlet. This is included in your accessories kit that will allow you to make sure that no particles are coming in. You'll also want to make sure that you have a liquid vial or your sequential installed, or else air won't flow through your growth tube and dry your wick off over time. After that, they want you to empty your water bottle and then empty your water supply bottle and empty your waste bottle just to make sure that there isn't any extra water that'll be injected in. Yep, that's what we'll see there. And then after that, the system will clear the lines of the instrument out to make sure that there's no water in the lines. After this, oh yeah, we'll have to wait. Dry not completed because I hit the enter button. Sorry about that. So what I wanted to bring up is that after the lines are cleared, what will happen is that a dry set of sampling here, so the temperature stage is not being cold here so that you don't condense any water onto the wick, will begin for, I believe it's 8 hours or 6 hours. And the reason for that is that we want to dry this out quite a bit. You don't need to dry it for that long. We recommend drying it for that long. I know it's hard to do on a Friday sometimes, but what's most important, I would say, is to make sure that the instrument's growth tube is cleaned and that you do get some draining and drying done. We'd prefer the whole draining and dry process done, but we know that sometimes it's not always possible. You can leave it to drain and dry overnight if that's something you need to do as well. And then things circle back around. Final thing I wanted to show off, once your wick is wet, your temperatures are correct, and you're ready to have airflow run through the instrument to run a sample, fill this vial with water or prepare a clean sequential sampling plate, put into your sequential, load it into the bottom of your instrument, And then all we have to do is hit the pump on button, and you're sampling for as long as you'd like to have an aerosol sample for. It'll keep sampling, keep pulling aerosol in until you end the pump button, or if you have automatic sampling going in some way until the time is elapsed. The timing of the sample will show up here towards the bottom if you end up doing that. And with that, I am going to talk one more time about error indicators. If you're seeing your liquid vial have its liquid blown out, or if your sequential plates here are getting blown out in some way, you're seeing liquid in your trap bottle, or even if just sampling isn't going well in some way, that's an indicator of an error, and feel free to contact Aerosol Devices. I'd be happy to walk through your experimental setup and make sure that everything's okay. With that, we are now going to end the fun part of our demonstration. Perfect. And go back to sharing screen for part 3. I am going to make sure that I didn't miss anything here. All of this, I can send you this slideshow if you'd like, but it's all the stuff that we discussed. Great. Oh, one other indicator of error on the machine, I'm glad I didn't miss this, is if water is not exiting your supply bottle, so going into your instrument, or being removed to your waste bottle. If you are not seeing water entering either of these paths, your liquid pump, one or the other, may be stuck. And that would be an important thing to note and fix because it can damage your instrument. It's pretty rare, but after drain and dries, it sometimes happens. Great. Finally, we are on to special considerations, and then I will be out of your hair. First thing in the special considerations section here to think about is aerosol concentration. This used to not be as much of a big thing with the spot sampler, but now that we see people doing more bioaerosol studies involving chambers, it has had to be something that we discuss more over time. One of the things that makes our system unique is that we are using water condensation onto particles to capture them more efficiently. That means that the thermodynamics, though, break down above a certain aerosol concentration. Specifically, if your aerosol concentration in your chamber, or that you're sampling generally, is above 10 to the 5th numbers per cc, which you can count on a CPC and OPC, stuff like that, we cannot promise our 90% for liquid, 95% for solid collection efficiency anymore. This is just because you can't grow the droplets big enough at higher concentrations to capture properly. You'll still capture plenty of stuff. We just can't capture the highest efficiency that we possibly could. The example that I like to give is that if you are either nebulizing directly into the inlet of your spot sampler or smoking a cigarette into the inlet of your spot sampler, you won't see the same returns as if that aerosol was diluted below this threshold. An important thing to note, remember that aerosol concentration, it is across the full range of 5 nanometers to 10 microns. So even if you have a particle counter that goes 1 micron to 10 microns, let's say, your 1 micron measurement is here, your 10 micron measurement is here. Let's say that on the y-axis, you have your numbers per cc, and your particle concentration looks like this. If you only have a tool that measures in this range down to this 5 nanometer section, you might have more particles that you're not seeing that are influencing what your actual aerosol concentration is for the sampler to work properly. So if you're having trouble, hospital room studies, ambient sampling studies, any ambient sampling, very unlikely that you'd be above 10 to the 5th, but for chamber studies, this is something to wonder about and talk to me about if needed. Great. Additionally, viability in bioaerosol sampling is a very cool new upcoming trend of capture. One of the things to note is that it is more difficult than standard bioaerosol sampling. A lot of things have to go right. Your limits of detection are different. You're sampling into liquid. You'll want to look at successful papers that have sampled viably to understand, how you might capture your certain bioaerosol. So feel free to reach out. Feel free to look at other literature, look at the Aerosol Devices references page on our website, and we'd be happy to help to make sure that we can make your experiments as successful as possible. Cool. The second to last thing that we'll be talking about is liquid level change during sampling. So with the spot sampler, you are sampling into a nominal 500 microliter vial. It's a pretty small amount. And if you're spending, over 2 hours sampling into the same liquid sample, which a lot of people want to do to have a concentrated sample, you can start to see gain and loss of water in your vial. Keep in mind, that's a function of concentration of aerosol, length of sample, volume of liquid sample you'd like to maintain. So I want to go over briefly how to maintain that in a liquid sample. Keep in mind, this is not a problem if you have the TLC. The TLC automatic controller does this for you. But with a lot of people doing it without, I want to make sure that I can go over this on the YouTube video so we can discuss it as well. So over longer time periods, what you start to see is that for any given moderator temperature, for any given liquid volume, your liquid vial volume is going to change. A common misconception, people a lot of times think that it has to do with external RH. External RH actually doesn't matter at all, because no matter what the RH is upstream, we are always going to a higher RH above 100%, 140% effectively in the initiator. So the things that do matter here are the temperatures of our liquid vial, the concentration of our aerosol, and the temperature of our moderator, which we will discuss in a moment. The reason being, our moderator, because it's downstream of the supersaturated section, is always at 100% RH, but it's at 100% RH for whatever the temperature of the moderator is. So the colder the moderator, the less water vapor that 100% RH air can hold. So we're effectively changing the amount of water vapor in our airflow by changing our moderator temperature. There we go. So a closer look here. When you are operating the instrument such that the moderator temperature is high, so 20 degrees Celsius, and your sample temperature is relatively low, let's say for some reason the temperature of this vial is 10 degrees C, you will see condensation of liquid in your sample vial over time. The reason being, just water vapor in the flow is condensing onto the surface of the liquid here. That makes sense. And that is also agnostic of the aerosol concentration coming in. It's just the thermodynamics, right? Water vapor, warm water vapor, a lot of water vapor here contacting a cold liquid surface. Inversely, if your moderator temperature is relatively cold, let's say 10 degrees Celsius, like you have it for solid sampling, and your sample temperature is, let's say, room temp, so decently warm, 20 degrees Celsius, water is going to evaporate from your liquid vial over time. Low amount of water vapor here, warm surface here, it's just not going to condense as much. And what that means is that you can control your moderator temperature. Since we can't control the temperature of this liquid vial, it's effectively whatever room temp is, right? We can control the temperature of our moderator to control liquid gain loss in the vial. However, there is one other question mark looming over this, keeping it from being perfectly simple, which is the concentration of aerosol. Since we are growing particles in the air into droplets, we are adding water volume via these little raindrops falling into the sample as well. So high concentration aerosol being sampled is going to produce more water in your liquid sample than low concentration aerosol is. It's something you can approximate, but it causes things to not be perfect in your sample. So if your aerosol concentration fluctuates wildly over time, that might be why you see variation in your liquid vial over the course of, let's say, a 24-hour sample. And we know why this would be bad. If you're evaporating too much, you're going to evaporate your sample away or reduce your collection efficiency. If you condense too much, you're going to blow all of your liquid vial out of your sample and contaminate it. So how do we control these things? So there's a few ways that we can control these longer liquid samples. One is to set our moderator temperature appropriately by putting a filter on the inlet and seeing what our effectively gain loss of liquid is while controlling our experiment to not have liquid drops come in. That allows you to get your moderator into the right ballpark range for liquid sampling, 18 to 20 C. However, it isn't going to be perfect because once you have particles coming in creating droplets, you might need to adjust your moderator down as well. And at some point, this becomes more art than science, dialing in your moderator temperature just right, starting with a large volume and kind of evaporating it down or condensing it up from a small volume is pretty tough, which is why we built the automatic controller. So if you end up wanting to sample for longer than a few hours, feel free to hit us up. Just a small reminder, you do not need to worry about this if you're sampling for 5 to 10 minutes at a time and you're hitting your limited detection, right? It's only if you're sampling for a longer period of time and you're seeing this gain loss in a liquid sample. Cool. Final section. I will try to keep it quick. Growth tube decontamination. So as the spot sampler has been used for more and more bioaerosol sampling experiments, we've wanted to make sure to bring up how to properly decontaminate the spot sampler to make sure that it is properly keeping people safe and providing high integrity samples. So these spot samplers materials are pretty chemically compatible. They have been designed that way from the get-go. Specifically vaporized hydrogen peroxide. At one point, when we were designing the next round of this, I talked to some companies that make VHP systems and made sure that our materials were as compliant as they could be. So materials like acetyl plastic, aluminum, polyurethane, stainless steel, polycarbonate, Viton, polystyrene. In our experience so far, all of the cleaning chemicals that I'm going to recommend to you pass extremely well. And then if you need, more boutique options, you can also contact us as well. So 70% to 100% isopropyl alcohol, methanol, and ethanol, totally fine, totally perfect to use in the system. Vaporized hydrogen peroxide, as well as if you flush it out with water afterwards, 3% to 5% hydrogen peroxide is fine. And for the stainless steel parts, so the nozzles, the inlet, the vials, you can also remove those and autoclave them, sonicate them, and use more aggressive cleaners as you see fit. We know that it's not a one-stop shop for decontamination. So as far as determining the frequency that you clean your instrument, that is always a question that I get. And the problem is that it is partially a function of how you use the instrument and what it's coming into contact with. If you are sampling in an environment that you're, an aerosol chemist or an atmospheric scientist, you honestly very rarely need to clean the spot sampler. The wick itself, as long as you're, isopropyl cleaning every once in a while, you're drain and drying the instrument out, it's serving its intended purpose for your team. But if you're sampling SARS-CoV-2 or pertussis or other things like that, that is when this becomes more of a much more crucial process. So the first thing I'd like to talk about is the path that cleaning needs to happen the most, and also the path for cross-contamination. So as we want to protect people, and then we also don't want to contaminate our next sample down the line. And you think about it, samples go, aerosol you bring in goes from the inlet, it's turned into a droplet, boop, and is sampled into your sequential or vial. So your path here for cross-contamination is from the inlet to your sampling substrate. Past that, you don't have to worry about cross-contamination because you're removing liquid here, your water is clean coming in, and your air is being pulled out via vacuum. So that area, the growth tube, you will either want to put isopropyl alcohol or other cleaners into your water supply bottle and use the count function to inject those in, so 500 counts of your cleaning fluid. You'll then want to flush with double the amount of water if you do that. So we'll say, 250 mLs, 250 injections of isopropanol here, and then 500 injections of water would be a good way to clean things out. Another way to do it would be to, as we talked about before, remove the inlet and then just directly dose 3 milliliters of your cleaning fluid onto the wick so you can get it from the top. And then always clean with double the amount of water afterwards. You just want to flush any of the cleaning material out afterwards. Then after that, you would empty, of course, and clean your water waste bottle. The trap bottle can be removed for cleaning, but one of the things we like to talk about is that since I'm going to skip ahead 2 slides. Since your flow path here where air goes through, you're capturing your particles here. There's a trap bottle here capturing excess liquid that you can clean, and a filter catching all remaining particles. you do not want to run any liquid cleaner through the remainder of the flow path. It is not meant to take any additional liquid cleaner. So the system itself, what you're really cleaning is the liquid wetted paths here. And then, of course, any external surfaces. And that's your best odds here of making sure that you are not causing any contamination or cross-contamination. That said, here we go. The way to determine your frequency of cleaning, in my opinion, is to run the amount of bioaerosol samples or aerosol samples that you want to run, and then put a filter on the inlet of your instrument and run a blank. This means you have no incoming particles in place, and you can sample into your preferred substrate. And as long as your sample substrate comes back with a control, no particles on your microscopy substrate or in your sampling well or in your liquid vial, it doesn't show up for your limited detection for bioaerosol capture, you know that you're not seeing cross-contamination in some regard. So typically for chamber studies where there's high volumes of sampling, I typically tell people to clean their wicks at the end of a day of sampling, just to leave it clean overnight. At the latest, cleaning at the end of a week of sampling. And then for people doing ambient field studies, typically cleaning at the end of a week of sampling so that it stays clean over the weekend, and that you might be draining and drying it after that. Or at the most, if you're not really doing bioaerosol stuff, running isopropyl at the end of a month of operating the instrument. But definitely before storing it, definitely before shipping it, you want to clean it and then operate a drain and dry on the instrument itself. Additionally, cleaning the outside of the case, alcohol, VHP, your preferred cleaning material, wipe, will work fine. The outsides of these instruments are made of epoxy-coated metal, so you shouldn't be able to worry too much about it. Generally, though, even for the stuff that I didn't cover, please feel free to contact Aerosol Devices and myself with any concerns about a cleaning chemical or safety or anything you want to work with in decontaminating your instrument. Finally, we are done. This is the outro. Please do not hesitate to contact us if you have questions about this video, operation of your instrument, or anything else about Aerosol Devices instrumentation. My job is to make sure that all of you that are using the instruments are as successful as you can possibly be. And I believe in these instruments and being able to do what they say on the tin. And if they aren't doing that, I want to be able to help. So please feel free to reach out. I hope this video was useful today. And reach out if you have any questions. And best of luck in sampling. You all are the future of great science happening, and Aerosol Devices is happy to be a part of it. So thank you very much, and have a good rest of your day.